Small differences can make a big change.
When you have not really a hard-working team behind of you, this is not possible to make.
In the end, bringing everything together, that was the most challenging part.
If you have the right mindset and you have the passion, it's a recipe for success.
We never stop.
I think we go ahead with the old area what we had in the past with the RC8, with the old RC8. We go a step forward with a new bike concept, and of course this bike is different compared to the RC8, but it's a full-fare bike. And I think also the whole company is very proud to have this bike again back in the product portfolio. The first riding test was to double check the ergonomic things. That was the first thing what we developed, and of course there was a lot of question marks behind, the requirements, daily usability, but also possible to ride on a racetrack, and that was difficult. For the development process, we have different milestones, call it P1, P2, P3 for example. P stands for prototype, and these milestones goes until the SOP, the start of production. The time between P1 and SOP, start of production, it's around 2 years. We start with a Frankenstein bike. It's not really an official bike, it's just to double check it's really possible to go in this direction. After this Frankenstein bike, we have kind of a defined project start, and at the same time we have also a defined project end with the SOP, and you have this time between start and the end to develop this bike. For this project we built up 12 bikes. These are then bikes for different departments. For example, one bike is for the designers. They make the CDG process on one of this bike. One bike is, for example, for our EE department, for the electric department. Then we have an extra bike, of course, for us as a development bike. Then we have durability test bikes. The bikes are running on the durability test for double checking the quality.
We are the simulation and test field department. Usually we step in the project in a quite early phase, because when we have the idea to build a new bike, you need data to prove it and you need data to build the bike. So usually we take data from an old bike that's quite similar to the bike we will build, and then is this the base for the first prototype. When we have built the first prototype, we can build our data bike out of it and back up the data for the final product in the end.
We as a development team, we are super lucky to have the most of the people here in the house in Austria. That makes the project himself or development very efficient. We have really short ways to find decisions directly in front of the bike.
We are responsible to collect the data for the other teams, to feed the other teams, our teams here in the department, with a huge amount of data, to set some new simulations, some new calculations, some new stress analytics of the bike. So we spend our collected data to the other teams to work with our collected data. For us, it's really important to have some measurement equipment that's really durability. You can test every time, because it's not like in the MotoGP when you take a sensor and then you ride on a race and then the sensor is gone away. So we always need our setups. The most of the time we can provide every data you want, because for sure we have to work really, really hard for this, but there is mostly nothing we can't do, for instance, because we have every possibilities you need, because we build up our 3D printed tools by ourselves and every bracket we need and everything. Here you have every possibility.
You know, there's a lot of guys involved in the project. Right now we have data engineers, suspension engineers, mechanics, electric engineers, chassis engineers, aerodynamics.
In the first steps, where we have the 2D sketches from Kiska, we can give them first feedback from ourselves just by looking on it to say some basic examples, the wing, where would be the best position, the size of the wing, and for thermal management, quite important for like a full fairing bike is the radiator outlet. When you get it bigger, you can cool more easily. So these are some things which we can do on 2D sketches, but aerodynamics is quite complex. So when you change something in the rear, the front also will change. And for that we need a 3D modeling. So our real work starts when we get surfaces from Kiska, so then we can simulate this in the CFD analysis. And with that we can give more precise feedback to the designers and work in our own world to get some concepts and test them virtually and then later also in the wind tunnel. For the digital world we use simulation, but we have to test it in the real world and in a simplified manner. And for that we use the wind tunnel. It's a big fan where we then have a smooth air flowing through the bike, and then we can measure all the forces. And also we can visualize also the airflow with a fog probe, so we have like air streamlining on the bike, and then we can put it on special parts and see how are the effects of the wing or of the fender or something. And the wind tunnel is perfect to measure every forces and then to know, is your CFD correct, can you validate this, and then after that we can take the best versions and put it on the track. The rider is a very important part on the bike because he is quite large on the bike. So for the wind tunnel, for us very important that he has always the same position so that we can compare the variances or the difference in our concepts. We have a sketch of him so that we can say to him that he has to move a little bit so that he sits like the run before. And also for him it's very important so that he can have the same environment, the same position, that he can give us the feedback which is corresponding to the first version, because when he is sitting a little bit different, he will feel something different. And it's not good when you have different concepts, so you want to know that in the same position why it's different and what is different. And also to test this with different riders. So another rider has another different natural position on the bike. So then it's for us a new person, and this new person gives us also different feedback about the same concept. And then we know, is this concept for different persons also good? In the winter we can also turn the bike, so the whole bike is moving to the side, and then we are simulating side wind. So in the natural world you have every time a little bit wind, so the air isn't directly coming perfectly from the front. And to see how our aerodynamic concepts are with this side wind, because it's a more unsteady world, because you have a larger side surface which is affecting from the wind, and this can cause some problems for the rider and also for the bike too. So we have to make sure that the bike is rideable in every situation, even with side wind. We have ex-MotoGP, IDM or Super Sport riders which can feel the best of the bike, and for that they have really good knowledge also to give feedback, and for us in the development this is quite important.
When I started at KTM, this was something I was dreaming of, because this gives me the chance to give back my experience into a project as best as I can, because that's what I've been doing all my life, for sure. It's not only racing bike, it also needs to perform on the road, on the street, and needs to be fitting to different people and different customers. But still, in this project I can bring in most of my experience to make it as good as possible. I raced actually now the top of the MotoGP field. I raced with a lot of them. I even raced in the German championship with Jack, and we had a few good battles and a few good races. So yeah, Jack, Brad, so the whole KTM factory team actually I raced with together in Moto3. I mean, it's very difficult to make a bike for everybody, that's clear. There is tests that I need to first go my direction, because if we do a track test, then for sure I need to be up to speed and have the bike how I like it, to be fast enough to make good comments about it, to use my experience to set up the bike. But there are definitely directions in a bike regarding very tall riders. You need a different ergo than a very small rider, so you need to be somewhere in the middle. You need to find a good solution for everybody. This comes with experience, I guess, but always have an open mind about what the customer would do with the bike. How tall would he be? How small would he be? How fast would he ride? This kind of stuff for sure is important to make a very good project in the end, make a very good bike. So this is for sure ideas I keep in my mind when I do work on the projects. Yeah, through the testing program, we choose different tracks to do different tests for sure. Went to Almeria first, working out a lot of the aerodynamic stuff, which is important at the beginning of the project. Went to Cervesina to try a lot of ergo, try different seating positions to get going in this direction. I went to Castiglione to test out the new engine and the suspension there on a very bumpy track. So I think if we can find a good setup there, we are happy. The cornering ABS is a very interesting topic, because this is one of the most difficult stunts we have to do, let's call it like that, because it is kind of a stunt. For sure, at some point already the engineers are preparing a setup, so it's not we're starting with zero, but we can't know at the beginning of the test if it's already safe enough and you will not crash. So there is the test rider coming in, trying to find a good spot where he takes his limit and how hard he's starting to brake in the middle of the corner to try out the new function of the cornering ABS. And from there, we go up and down. We for sure make it as sporty as we can, but in this case the most important thing is not to crash whenever something happens in front of you, and you are spiking into the brake and using it very strongly, very fast. So this is the main thing about the cornering ABS, is you're not crashing and you're staying safe.
For the racetrack, we had some different wing concepts and also some variation in the wings. First of all, we tested different concepts and variations in the CFD, and this were the best results. Then we take them into the racetrack, and then we want to have feedback from the rider. Which downforce level does he prefer? Which downforce level is the one we needed, we wanted, and is also the one which is faster, because when we're increasing the downforce, so the natural load on the bike, we also increase the drag. So this makes us improve in cornering. For that, the rider has to give us the feedback which downforce level he wishes, and we have used same wing concept but have changed some little parts on the wing, like the angle of attack, so the angle of the airfoil, and for that it will create a different amount of downforce. And in the end, the test rider gives us the feedback which is the best one for him, and then we can proceed with this amount of downforce to reduce the drag, so then we can have a higher performance.
Die Runden bist du jetzt gefahren, 2, 3. Wir nehmen bitte die da so gerade runtergehen. Die ist ganz vorne. Ja, genau, die beiden. (1301), der liegt jetzt da. Das war jetzt der hier. Und der andere liegt da. Dann testen wir jetzt noch den.
Dynamics is a big thing, so there's a lot of different things that happen if you are playing around with those options you have. If you put a different wing which will have more downforce, it will drag down the bike more throughout the long corner, which will help you with the whole bike. It's not just about the front, it will also help you keeping the bike through in the corner, and you feel better on the rear. So there is a lot of stuff changing. Also a change of direction can be influenced really a lot.
Der Vorderbau ist einfach ruhiger.
Okay. Bestätigt sich von der Kurve an sich, von der Linientreue, sage ich mal.
Ist das eben auch am besten, weil du bist drinnen mit dem Körper und kannst nur ein bisschen nachziehen mit dem Lenker, und bei dem anderen brauchst du direkt einen Puls, dass du nochmal drüber kommst.
Ja, und auch von der Kurve her, weil der eine drückt dich ja, der Gerade, der drückt dich ja schon, glaube ich, nach außen. Das müssten wir jetzt dann nochmal anschauen. Der drückt dich schon nach außen und du wirst wahrscheinlich da auf der Geraden, jetzt mal da schauen, wo du da bist du eh schon wahrscheinlich so ziemlich gut am hübsch Kurven vorbereiten, wo schon langsam eine Schräglage anfällt in dem Bereich da. Genau. Und da denke ich mir dann schon, sagst du, okay, beim einen hast du ein bisschen mehr Vertrauen, du machst auch die Bremse wieder ein bisschen früher auf. Man sieht es, du fängst hier früher an und hörst hier später auf. Ja, und du verzögerst auch stärker, was man hier drin aussieht. Höhere Geschwindigkeit, zieht weiter runter und lässt ihn einfach schon durch die Kurve durchlaufen. Und bekommst auch wieder schnell raus hinten bei beiden.
The motivation was very high to change the handlebar position, change the seat shape, change the footrest position. Of course, it's definitely not possible to have a steering angle like a Duke. You need to reduce the steering angle. We double checked this with different bikes from different brands. What is the real range for that? Then we provided different bikes with different steering angles, and it was really hard to find a decision because they have a lot of influence in the design phase for the windshield and the parts around. You cannot steering so much, otherwise you have a collision with the handlebars and with the levers. You have cutouts there. And this is driven by the steering angle from the handlebars, and it's of course fitting to our current MotoGP bikes. They have nearly the same shape there, and this is the reason why you have this shape there on the bike.
It is a very, very important task to go to different tracks because they vary so much in layout that you have big corners, small corners, hard braking zones, long corners, short corners. So the bike needs to be working on every track, if best on every track. So this is what we want to do, and that's the reason for testing a lot of different tracks. It has been just 2 months trying out and testing a lot of ergo in Cervesina at the track. So for sure to find a good seat position on the bike is very important.
Da ist mit dem Herren ist besser, weil man nicht so viel auf dem Plastik sitzen.
On the racetrack you want a lot of support going through the corners, so everybody can imagine if you're hanging off with your knee and elbow on the ground, it's important to feel safe and feel good suited into the bike. So that's where we made a lot of changes, preparing different seats and trying to find the sweet spot for sitting straight, but also being able to hang off properly and have a good feeling when doing so.
Like 3 laps, and I already feel that I push a lot on the outside because they are turned in quite a lot. Okay. So now is the question, we first turn them out, straighter, or directly go down, but I would
go down.
Now I would actually go straighter and then start to go down.
Okay.
But let's talk with Franz also what he thinks.
Das war Standardposition offen mit den 10 mm, wie du vorher gefahren bist.
So bin ich
Du
gefahren.
das jetzt nur mal, wo du das ungefähr rum bist.
Okay.
Yeah, sometimes we also start to change the riding dynamics of the bike, make it shorter, make it longer. We sometimes take out the chain and change it to use different sprockets on the bike, making it a longer or shorter wheelbase, which is important to see if the bike is still stable enough, if it turns better, which it mostly does with the shorter bike length. And so we played around in this direction a lot, and it worked out nicely that we knew, okay, with a very stable bike we can do and play more in this direction to find a good sweet spot for then have gearing options for different tracks, because you will change your gearing when you come to a new track. It was important to us to make sure we try that first time.
Sagt man besser. Vor allem Fahrt hinten haut besser hin. Macht ein bisschen weniger Bewegung. Vorne nicht ganz so leicht. Front, wir gehen mit einer, Lenker sind gut, Fahrwerk passt auch besser und das schauen wir uns an.
You know Jeremy, one of our test riders. We were riding on a racetrack, and of course one of our requirements is to have a good setup on the bike for track use. And normally Jeremy is riding the bike on street and have something what he need to adapt or need to change. And on the racetrack is the same. And he was riding a few laps, comes in, and I was expecting he needs new springs in the rear, he needs harder fork, whatever. But he comes in, put the bike on the stand, and he said, "Oh, it's okay, it's okay." And that was for me a really big surprise. He said, "Yeah, did it like it is. It's a good bike." It was really a special moment for me, for myself. Yeah.
After the test, when we have downloaded the data, we look at it, that is reliable and everything is correct. When the data is correct, we progress the data in different ways for different parts of the bike, and then we make them available for a simulation team or a fatigue and test team to do the simulation and the test bench tests.
Our data are necessary for the applications of the engine, for instance, and also to the application of the suspension. And then for us, it makes us really happy when we see some new steps into the future with our collected data.
Nobody really stops here, so it's like the guys are always working, the guys are always trying to make the whole thing better.
It cannot stop.